What is that? What is really going on there? The thing is, when you ask why about anything, you need somewhere to stand. You need a few things you're willing to accept as true, at least for the moment. Otherwise, you're just falling forever through why, and it never stops. Let me show you what I mean. Why is your Aunt Minnie in the hospital? Because she slipped on ice and broke her hip. Fine. But why did she slip? Because ice is slippery. Everyone says that. But why is ice slippery? Now that's actually interesting. When you stand on ice, the pressure can melt a very thin layer at the surface. So in a real sense, you're not sliding on ice at all. You're sliding on water. Then you ask, why would pressure melt ice? Because water expands when it freezes, which is unusual compared to most substances. So pressure tends to push it back toward the denser form. But then you can ask, why does water expand when it freezes? And once you start, notice what happens. Why did she fall when she slipped? That's gravity. Now you're talking about planets, mass, and the structure of the universe. Why does falling hurt? Why did her husband call the hospital? Because he cares about his wife. Does he? Not everybody does, especially if they're angry or drunk. You see the pattern? Every answer opens another door. Each because creates new questions. If you don't decide where to stop, you can keep asking why until you run out of energy. People often want me to explain things using something familiar, something they already feel they understand. They'll say, maybe it's like rubber bands. Maybe there are invisible rubber bands connecting the magnets, pulling them together. But that kind of explanation is cheating. If I say that, you'll feel satisfied for a moment. Then you'll ask, why do rubber bands pull back? And then I'd have to talk about forces between molecules, which are electrical forces, the very same kind of forces I was trying to explain in the first place. So I'd be going in circles, using the mystery to explain the mystery. That's not understanding, that's a trick. Electrical and magnetic forces are fundamental. They're bedrock. We do not explain them in terms of something simpler. Instead, we explain other things in terms of them. Chemistry is, at its core, electromagnetic forces acting between atoms. Biology is built on chemistry. The chair supporting you right now is electromagnetic. The reason your body doesn't simply collapse into a heap is electromagnetic. It's everywhere. It runs almost everything you experience. Here's something amusing, though. You don't find it strange that you can't put your hand through a table. You press on the table and it pushes back. That feels completely normal because you've done it your whole life. But your hand never truly touches the table in the way people imagine. The atoms in your hand come close to the atoms in the table, and the electrons begin to repel one another. That repulsion is what you feel as solidity. That is what touching is. The same force, the exact same kind of force that shows up with magnets. So why does the table feel obvious while the magnet feels mysterious? Mostly because you grew up pushing on tables every day, and you didn't spend your childhood pushing magnets together all day. The table is just as strange. You simply stopped being surprised by it. Electrical forces are not merely strong, they are unbelievably strong. Compared to gravity, electromagnetism is stronger by an absurd, unimaginable factor, a number so large it's hard to even talk about in ordinary language. It isn't a little stronger, it's ridiculously stronger. So why don't we notice that dominance all the time? Because matter is usually balanced. Positive charges in the middle, negative charges around the outside, plus and minus, arranged so that most of it cancels out. The most powerful force in daily life hides in plain sight because it neutralizes itself. When you comb your hair and pick up tiny bits of paper, you've shifted only a small number of electrons, just a slight imbalance, yet the force is so enormous that even that tiny imbalance produces an effect you can see from a distance. Magnets are special because of what happens inside certain materials, especially iron. Electrons have a property called spin. In most materials, those spins point in all directions. Chaos. The tiny magnetic effects cancel each other out. But in iron, many of those spins line up. They cooperate. And when they cooperate, the little effects no longer cancel. They add, they reinforce, they amplify. Suddenly, you get a magnetic effect that reaches outward, something you can feel without direct contact. That's why iron becomes strongly magnetic, while copper does not. Copper has electrons too. It has the same underlying rules, the same forces, but the spins are not aligned in a coordinated way. It's like a stadium full of people. If everyone speaks at once, you hear noise, nothing distinct. But if everyone chants the same word together, you can hear it far away. Same voices, completely different result. Now let's go deeper. What is actually happening when two magnets pull toward each other? At the most fundamental level, it involves particles being exchanged. Electrons don't simply sit still like tiny beads, they interact constantly. In quantum theory, they exchange photons, little packets associated with light. Not necessarily the visible light you see with your eyes. These are what physicists call virtual photons. They exist only during the interaction. You cannot trap one in a jar and examine it directly. One electron emits, another absorbs, back and forth. That exchange is what we experience as electromagnetic attraction or repulsion. It sounds strange, objects pushing or pulling by throwing things back and forth, but that is the description that works. Every time you feel one magnet push against another, an unimaginable number of these exchanges are happening between the electrons in both pieces of metal. And here's the beautiful part. Everything electromagnetic can be built from a very small set of basic processes. An electron moves from one place to another, an electron emits or absorbs a photon. That's it. From those basic ingredients, you get chemistry, light, magnetism, electricity, radio waves, the colors you see, and the simple fact that your hand stops at the table instead of passing through it. There aren't hidden gears beneath the surface. There isn't a secret mechanical device underneath. People ask, but how does it really work? And the answer is, this is how it really works. Exchanges, interactions. That's the bottom. That's as deep as the explanation goes. Long ago, scientists worked out the full mathematics of electricity and magnetism and unified it into a single framework. The equations that captured this unity transformed human life. Because once you understand the changing electric and magnetic effects are connected, two aspects of the single phenomenon, you can do things with it. You can make a current in a wire create a magnetic field. You can move a magnet near a wire and create a current that flows back and forth. Electricity and magnetism are linked. They dance together. Think about what that means in practical terms. Somewhere there's a dam. Water falls and turns a large wheel. That wheel drives copper wire near iron. Because the copper moves near the iron, electrons begin to move in the wire. That movement travels through thin lines of copper spread across a city, and at the other end, another arrangement of copper and iron converts that electron motion back into turning motion. All the wheels in the city turn because one wheel at the dam turns. Stop that one, everything stops. Start it again, everything starts. And what makes it possible? Just copper and iron. No magical substance, no mysterious fluid. Just the fundamental behavior of electromagnetism. You move iron here, and far away iron moves over there, connected by nothing but copper wire. Nature is astonishing. We built our world on this. Lights, motors, machines, all of it running because electrons flow through wires.
Now here is something remarkable. We can calculate how magnetic an electron is. Not guess. Not approximate, calculate, using only those fundamental processes, photons moving, electrons moving, emission and absorption. You add up all the possible ways it can happen, all the paths, and you obtain a number. Then you measure what nature actually does with extremely precise instruments, and the calculation matches. The agreement is so good it's almost hard to believe. It's like measuring the distance across a continent and being accurate to something as thin as a hair. That kind of precision is rare in science. It may be the most accurate prediction humans have ever made about the physical world, and it comes from understanding the electromagnetic force. The same force you felt as a child when you pushed two magnets together. So yes, we can describe magnetism with extraordinary precision. We can predict exactly what it will do. But can we explain why electromagnetism exists in terms of something simpler and more familiar? No, not because we failed, but because electromagnetism is one of the basic things. It is the familiar thing that explains everything else. There is also a constant in physics, a particular pure number that sets the strength of electromagnetic interaction. Physicists can measure it with extreme accuracy, and it appears everywhere in the equations, but nobody knows why it has the value it has. We did not derive it from something deeper. It simply is what it is. If you ask why that number and not some other value, there is no final answer. It remains one of the great mysteries in physics. If it were significantly different, atoms would not hold together the same way. Chemistry would be different. Life as we know it might not exist. The universe depends on that value, and we do not know why nature chose it. Now, there's a historical point worth mentioning. When physicists first tried to compute certain magnetic properties of the electron using early quantum theory, the equations produced nonsense, infinities. That is not an answer. For a long time, this was a serious problem. Later, a method was developed that handled these infinities in a way that produced finite, meaningful results. The idea is that we never measure a naked electron all by itself. What we observe is always the electron plus its surrounding interactions, the constant exchange processes. So you begin from what you actually measure, and the troublesome infinities get absorbed into the measured quantities. The predictions become finite. Some people find that suspicious, as if the mathematics is hiding a problem. But the results match experiments with stunning accuracy. So perhaps this is simply how nature must be described. Now, here is the deeper point about understanding magnets at the most fundamental level. Quantum mechanics does not behave like everyday experience. Your brain evolved to handle rocks and trees and animals at human scale. But electrons do not behave like tiny planets orbiting a nucleus. People say electrons behave like waves. Not exactly. Like particles? Not exactly. Like a fog? Not quite. If you want a simple, clear mental picture of what is happening inside a magnet at the atomic level, a picture you can visualize like gears turning, I cannot give you one. Nobody can. What we have is mathematics. We write equations, we calculate, and the predictions match reality with remarkable accuracy. It's like a machine that computes perfectly when something will arrive at a destination. It does the arithmetic flawlessly. It gives correct answers, but it has no mental image. It does not see anything. It just calculates. That is what we can do with magnetism. We calculate what magnets will do. We are extremely good at it, among the best achievements in all of science. But the intuitive picture, the ability to truly see what is happening the way we see everyday objects, that may be beyond us. Nature at that scale is genuinely different from what we evolved to understand. And that brings us back to where we started. You push two magnets together, you feel the force, and you ask, what is that? The honest answer is, it is electrons exchanging virtual photons. It is spins aligning inside iron. It is the electromagnetic force that holds your body together and runs the universe.
We can describe it with spectacular precision, but if you want it explained in terms of rubber bands or springs or some everyday mechanism you already understand, I cannot do that, because those everyday mechanisms are themselves explained by electromagnetism, not the other way around. Magnetism is not the mystery that needs explaining. Magnetism is the explanation. It is not some isolated phenomenon. It is part of the electromagnetic force, one of the fundamental forces of nature. Every atom in your body depends on it. Every chemical reaction depends on it. Colors, touch, solidity, compasses, motors, it is all the same underlying thing. And it all comes from that small set of basic actions: photons moving, electrons moving, emission and absorption, combined in countless ways. There are no hidden gears underneath, no deeper mechanical story hiding behind it. This is how it works, and the fact that we can calculate it and match experiment with extraordinary accuracy is not philosophy, it is experimental science. If the prediction agrees with measurement, then the theory is right. Does that mean we understand everything? No. That mysterious constant still has no deeper explanation. We cannot picture quantum behavior the way we picture ordinary objects. Our mental images remain approximations. But physics is experimental. You do not sit around waiting to understand everything perfectly before you move forward. You learn enough to predict what will happen. You test it, and if it works, you use it. That dam, those wires, those motors turning across a city, that works because we understand electromagnetism well enough, not perfectly, well enough. And when you ask why magnets attract, what you usually want is an answer framed in familiar objects: springs, rubber bands, invisible strings. But the truth is that magnetism is the familiar thing. You just didn't notice. Every time you have touched anything in your life, you were feeling electromagnetic forces. Every solid surface is electrons pushing against electrons. You have been living inside electromagnetism since the day you were born. Magnets simply make it obvious. They let you feel at a distance what is normally hidden at tiny scales. So the next time you pick up a magnet and feel that push or pull, don't treat it as a weird exception. Think of it as nature revealing something honest, showing you directly what is usually invisible. The same force that holds your own hand together is acting through the space between two pieces of iron. That is what is happening. That is what you are feeling. And the fact that we can describe it and predict it so precisely is not magic. It is what happens when you pay attention to what nature does and write it down carefully.